Greetings, children. Today we're talking more about working with factoring out monomials. And we're going to talk about factoring out a monomial when it doesn't really look like a monomial as well. But first, let's talk about what happens when you have a bunch of terms. So, we looked at several examples in the previous video where you have just a couple terms. But now, what if you have 4 or 5 terms? Like, what if it's 5x to the 5th plus 4x to the 4th plus 3x cubed plus 2x squared plus x, right? So what if you have a bunch of terms like that? Well, it still works the same way. You see, what can you factor out of all of them? Well, all they have in common is just that one x. So this would be x times 5x to the 4th plus 4x cubed plus 3x squared plus 2x plus 1. Right? Remember, when you're factoring out the entire term, like that x at the end, you still have to leave that 1 in there, either plus or minus, whatever it is. So that's what it is if you have a bunch of terms. It's not really all that scary. You just have to make sure that it's common to all the terms when you're factoring. Now let's look at a couple examples when we have a common factor that is a polynomial itself. So you may have noticed in the work from yesterday that you had some that looked like this. X times, and then it was something like y plus 3 plus 5 times y plus 3. Now, the x and 5 here aren't common, but this whole group, this y plus 3, is common to both. So we're actually going to factor out that group, y plus 3, and then when we divide this by y plus 3, we would have x times y plus 3 divided by y plus 3. Because that's what we do when we're factoring out. We divide each term, cancel, and you're left with x, and over here you'd be left with plus 5. And just like always, we put that in parentheses. So let's think if we had something like this. X times y plus 5 times y, right? You would factor out y, and then you'd have x plus 5. Well, this works the same way. You can see the similarity there. It's just that instead of y, it's y plus 3, and it's a group. Now, it has to be grouped like that. You can't just factor out y plus 3. It has to be in a group. And when you divide, or when you get your answer, you'd have y plus 3 times x plus 5. Let's look at a few more examples that look like that. Let's say we had 2x times y minus z minus 5 times y minus z. Notice again, y minus z is the common term, and you're left with 2x minus 5. So this skill comes into play later when we're doing something called, when we're doing factoring by grouping is what it's called. So we'll see that later in this chapter as well. Let's look at one more example of that. Let's say we had x times 2x minus 10 minus 3 times 2x minus 10. So we have 2x minus 10, that's our common factor, and we're factoring out x minus 3. So that's our answer. So that's it. Let's do one more thing though. Let's prove that this is actually the same thing. Right? I'm going to move this down a little bit. We said our answer was 2x minus 10 times x minus 3. So let's multiply this out with the distributive property. We get 2x squared minus 10x minus 6x plus 30. Combine these like terms, we get 2x squared minus 16x plus 30. Now let's use the FOIL method on this. we get 2x squared minus 6x minus 10x plus 30, which is 2x squared minus 16x plus 30. And if you look, those answers are the same. So that's how we can show that those are actually equivalent. So this is the correct factored form. Alright, well that's it for today. Just a short little video explaining some of the things that you may have already worked on, but may not have understood it quite as well as you could have. Thanks. Have a great day.